Okay, today we're going to be looking at L'Hopital's rule. L'Hopital's rule is a way to find the derivative, is a way to use the derivative to find a limit that is indeterminate. So if you're trying to find a limit of a quotient, f of x over g of x, as x approaches a, let's say, but a can be a real number, or it can be infinity or negative infinity. So really any type of limit that we ever try and figure out. And you get an indeterminate form, either 0 over 0, because we don't know what that is, or infinity over infinity, and those can be positive or negative. Those are indeterminate. We don't know exactly what a number going to 0 over a number going to 0 is, so we know we have more work to do. Well, L'Hopital's rule states that if that's the case, then it must be true that the limit that you're trying to find is equivalent to taking the limit of the derivative of the numerator over the derivative of the denominator. So let's see how we can apply that to find some indeterminate limits. Let me just get a problem right here for us. All right, we'll start with this one. Okay, so if we were taking the limit as we have x approaches infinity, I could plug infinity in for x, and I would get 5 times infinity minus 3, well, that's infinity. And then 2 times infinity minus 3, well, minus 1, well, that's also infinity. Now, you might know automatically what this limit is from your pre-calculus rules or from doing algebra with the equation, but I wanted to start with showing L'Hopital's, and one that we could actually do without L'Hopital's. So what we need to do to be able to justify L'Hopital's is we have to show that the numerator's limit is either 0 or infinity, and the denominator has to be either 0 or infinity as well. So let's start with the numerator, and we have to document our work this way. So I'm going to say that the limit as x approaches infinity of 5x minus 3, and I have to take this limit and I have to show that this is in fact indeterminate. Well, that's equal to infinity. Okay, so we'll mark that. Okay, now we'll try the denominator. And it's very important that we document these steps because we're showing that we know how to use the theorem. If you just jump to the next answer, well, then you haven't used the theorem properly, and you wouldn't get full credit for it. Well, that's also infinity. So then we'll just go ahead and justify this by L'Hopital's rule. Now you'll see the word L'Hopital written with or without the S. It looks like La Hospitals, but it's pronounced L'Hopital's. So I'll just say by La. I know that the limit, L'Hopital's tells me that the limit as x approaches infinity of 5x minus 3 over 2x minus 1 is equal to 5, because that's the derivative of 5x minus 3, the limit as x approaches infinity, the derivative of the top, and then the derivative of the bottom is 2. And now the limit of a constant is simply the constant. So what we know now is that the solution to this limit is 5 over 2.